Thank you, everyone. Thank you for all the amazing talks that we heard in this session about data sets and data synthesis. And thinking about kind of all the different talks, we heard about methods for generating data, data sets, including pipelines, crowdsourcing, generative models, and data synthesis tools. And I'd be curious for our panelists, in your opinion, what are the biggest opportunities to apply these methods? And anyone feel free to answer.
Let me kickstart the discussion then. So I believe the best opportunity to apply the various methods for data evaluation or data benchmarking is pushing the bounds that we already have in the already existing benchmarks. So if you have an AI system that performs well on certain set of well-known benchmarks, it's extremely important to see what it cannot do. And as soon as you can provide new benchmarks and as soon as you can provide the new challenges for your model, you can see the versatility of it. And currently, people tend to focus on very small subset of benchmarks or data sets for evaluation to claim the state of the art, the new awesome results. But however, to see how generic our models are and to see how well they can address some meaningful tasks, we need to constantly rotate the actual benchmarks, and we have to rotate the actual challenges that are supposed to be solved by these models.
Yeah, thank you. Oh, Austin, go ahead.
Yeah, so just to add a thought, just from our experiences with the sim to real docs, I think one opportunity is to change our mindset. So with synthetic data sets is to change the way we think about machine learning models, to kind of approach them. When you're working with like a synthetic data engine, you start approaching developing the machine learning model almost more like programming, because you say, well, I want my model to be, let's say, invariant to rotation of the document. And the way you do that is you synthesize data in which you rotate the camera, right? And so in that way, if you have the ability to synthesize data and control kind of the parameters of that synthesis, you can actually kind of deliberately program behaviors into your model in a more intentional way. And I think going from, right now when we use simulators, they tend to be ad hoc and domain specific, like, either simulators for robotics. And if we kind of get to a more mature state, we can use simulators in a way that we are kind of intentionally designing sort of behaviors into our models more deliberately. I think that's kind of a new way of model development that's really powerful.
That's a great point. Being able to be intentional about the whole process of the data that you have and testing parts of the model's performance by generating. I'd be curious, we heard a number of talks that talked about generating synthetic data, and there's always this kind of trade-off between what you know to generate versus what actually happens in the real world. So I'd be curious to hear from folks about using synthetic data and data generation techniques kind of proactively versus reactively in like the case that there is some incident or some kind of edge case that you didn't consider.
I think at least for us, like our attitude is that synthetic data is a necessary but not sufficient condition to validate the model. So for example, like let's say you use some synthetic data to generate GAN handwriting to test your OCR text recognition method. Well, you may not test the full you probably can assume you're not going to test the full distribution of handwriting. But if it doesn't work on your synthetic data, you know that it's definitely not going general enough. So you have this kind of attitude of it should work on the synthetic data as a kind of a minimum requirement, but just because it works on the synthetic data, you don't assume that it generalizes well. And then when you see where the gaps are, then you can, either you can use that information to kind of refine the space in which you're simulating.
So I like just to point out my vision about that. I'm from a very specific domain using machine learning, is the network intrusion detection. And the current, this network intrusion detection domain is very model-centric. So a lot of research is performed using well-known data sets, and currently we have seen the evolving attacks on networks. So for example, recently we see a vulnerability published last Friday called Log4j, and probably none of the data sets envision this kind of attack. So proposing methods to keep generating data sets with recent data, recent scenarios, and in focus, with the focus on the data for better data for these machine learning models. I see it's a trend to be followed. And when I saw the data-centric AI workshop, was like a mirage in the desert, because in our domain, we see this limitation on the research, and we saw the data-centric workshop, and we see, oh, this is somewhere that we can propose this discussion to kind of raise this critical thinking about the current trend on our domain.
That's awesome. Thank you.
And maybe to just go a little bit deeper into that point, how data synthesis can be actually very different in other domains, and different domains might approach things differently, like network intrusion detection. It occurs to me, it seems like just similar to some of the questions we had in the morning about keeping like text data up to date, like for example, for Common Crawl, keeping Common Crawl data up to date, you'd have similar problems in network intrusion detection of, how do you actually keep up with, new data sets and new attacks as they're produced rapidly. I'm curious if you have a perspective on that. How would you keep the data in network intrusion detection up to date?
Okay, currently we have open source databases that publishes the known vulnerabilities. And this is one of the possibilities to retrieve this information to generate new attacks on a test bed. And the other part of this way to work is when you already know the environment that you will deploy the model. So it's very difficult to transpose a model that you trained in a specific normal traffic to another environment. So to determine the attack samples, you can retrieve this public knowledge about it's very from the NIST database and the CVEs and so on. You can retrieve this kind of data, and when you already know where you're gonna deploy your model, you try to retrieve the normal traffic. Normally interfacing with the administrators of the network to bring their knowledge to support the development.
Yeah, thanks for going in detail there.
Yeah, great question. Actually, in thinking about domain-specific kind of cases, Lenore, material science, I think, is another great example of something that kind of a domain that people in the AI community, a part of NeurIPS, don't typically think about. And I'd be curious about your experience as far as what are the gaps in terms of tools and algorithms when we think about data and material science.
I think the biggest difference is that we work in small, sparse data sets. If someone, if we're thinking about kind of classic inputs, outputs here, we can think about things like what were the ingredients used and in what quantities, what were the processing parameters. And there are times where, in a multi-step process, what if the experiment fails halfway through? Then those final characteristics, those final outputs aren't even captured for that sample. And so how do we train a model to know that, don't even try this set of conditions when we don't have the measured final outputs because it didn't even get to that final material. It didn't even, maybe it just got burnt in your beaker somewhere. And so overcoming how to represent that in the data so that when someone's looking back on that experiment, they understand what happened, so they can model if that will happen or not, is something that yeah, I think is pretty unique to the materials case.
Thank you. Thank you. That's a great answer. You know, and thinking about kind of missing pieces in the stack, I'd be curious for the computer vision speakers. What did kind of data management look like for you? What was the stack of tools that you used, and was there anything that was missing there? Any tools that that you would like to have in order to actually simplify the workflow that you went through with creating your papers?
Yeah, I'll say we used tools like data version control, DVC, to share data sets across the team, and to basically, you know, we'd have kind of periodic runs of, you know, generating more synthetic data, retraining a model, and then sort of finding other cases, generate, and then over time, so you'd kind of layer these kind of stacks of data from kind of different experiments, and you know, so there are these kind of data versioning tools. There's kind of data pipelining tools, but if you look at how smoothly they're integrated, I think we have a long way to go. You know, there was discussions of, you know, HCI and UX design kind of from some of the earlier talks. And I think you see that as well here, where there are tools to sort of cobble together the versioning, you know, file sharing, you know, code and pipelines, but it feels like they could be one or two orders of magnitude more sort of like deeply integrated if you look at like where things are with CI processes, IDEs, and stuff like that in the software development world.
Thank you. Thank you. That was a great answer. I'll pass it over to you, Greg.
Any other thoughts on this question? I feel like potentially many of these data sets and data synthesis could benefit from tools.
I think one thing is like the simulator stuff. That's often a interface that's like really ad hoc. Like we use Blender, and there's not that mature interface between Blender and machine learning. And I think it'll be interesting to see where things go with like game engines and things like that if they start becoming more mature tools too.
So it seems like game engines like that weren't designed for this. So I'm curious, are you suggesting that, you know, maybe there would be a game engine that would be designed for data synthesis?
I suspect if you look at like where Unreal's going lately, and the way it was originally developed for game development, but it's being used in filmmaking to generate like photoreal scenes. I think tools like Unreal, as well as some of these kind of GANs that make sort of video game images more realistic, I think some combination of those will become pretty standard tools in computer vision. You see some use of that now, but I think that's only going to increase.
Thanks. Let's see, why don't we keep going on to some other topics? There are a lot of questions here. Let's see, so this one is for Christoph for Lion 400M. And there's a question about just how would you compare this approach of that you used to create this data set against something that's more traditional, like an image search engine? And then what would the strengths and weaknesses of each approach be?
So our project started as a community effort on a Discord server. And basically what I did, I started the project. I began on Colab just to try to look for a way to filter out image text pairs from Common Crawl. And I did lots of comparisons by manually just checking the quality. At first I did like 0.26 as a threshold, similarity, constant similarity between image and text clip encoding. And then I moved upwards and I found 0.3 is pretty good. 0.28 is also still pretty good. And we simply checked manually like a few thousand samples. And then we said, okay, let's keep moving. And we did a few million. We surpassed 3 million within 4 weeks with basically 20 collabs running all the time. And then more and more people joined and more hardware came in, and then the speed increased almost exponentially. And yeah, at the moment we're at an even much faster speed. So at the moment we already have unpublished 2.8 billion samples. We are now also going for multilingual data, and we will within the next 6-8 weeks probably finish all image alt text pairs from Common Crawl. Multilingual with MClip. This is like a language model adapter to make clip multilingual. And we actually have not much benchmarks or tests. We trained some DALI models, PyTorch DALI, and we found that, for example, our data converges much faster than conceptual captions. We didn't do an in-depth analysis because we are all like non-profit, for free people from Discord who work in our free time. And we have the hypothesis that probably because we did the clip filtering, we don't know which potential biases this introduces, but we assume that this is positive for convergence because we already have a pretty strict fitting of image and text. And if you want to find out more, you can check out our web demo, our graphical interface. It's like basically a search engine, yeah. It's like a AutoFize, a FIZE KNN index where you can quickly retrieve many nearest neighbors. And this is really cool because we have a button with like a download symbol, and you can get within like 5 seconds the 10,000 K nearest neighbor image text pairs for any prompt that you have. You can upload an image like Google search, image search, you can just type something. We will even soon add some features like adding and subtracting, like king minus queen plus whatever, like these kind of things. We will implement this into the web demo so that everyone could like just explore the clip space.
Great, thank you. Actually, a follow-up question on that. So the data set that you've created and the one that you're working on now is massive in terms of scale. And I'd be curious, especially as kind of like a nonprofit, smaller organization, how do you think about working at that scale and kind of compute and resources that are involved with data of that size?
Yeah, it's actually pretty crazy. We focused initially just on this scale like 400 million because some of our contributors are from the Helmholtz Society Jülich Supercomputing Center, who want to apply for compute time to train a DALI and open sources. This was the initial idea. And we grew together, and as the project grew, we founded Lion. And we also said, okay, for now we want to collect the data because this is cheap resource-wise, because we don't need GPUs so much. Only 3090 at the moment are doing clip inference, and they can get like 80 million samples after clip filtering per day. So this is really cheap. But as Lion 400 was released, we got in touch with Hugging Face. They are now funding us a little bit, supporting us. And now some other people showed up, and we are now in touch with Mila from Montreal and talking about collectively organizing supercompute grant applications so that we can like write them one time, then change them a little bit for a specific task, for like basically for the idea for training things like Clip, DALI, NUVA, maybe in the future, whatever foundational models, big. And we will collaborate and like exchange some tricks on how to apply and how to frame the application. And as we were doing this, like in the last 2 weeks, we were contacted by someone who is a former hedge fund manager and now interested in investing in AI. And we have someone who said, as long as we like promise to open source the results, he would be willing to provide us with pretty much many GPUs. Like, and we are at the moment trying to coordinate training of something like a big clip-like variant. Like we are exploring the Philip implementation and the Globe paper, We have actually been in touch with the Globe team from Hochreiter, and we have been in touch with the Philipp team, like Mailwise, and we want like to re-implement it and combine and find out what works best together, which tricks regarding the new clip variants. And then we want to train a really big clip in this at the scale of Turing-Bletchley with several billions of samples, and open source is completely for free. So this is currently the plan, and we have someone who will give us this compute. He already gave us a little bit, and he is currently in negotiations with AWS. Yeah, I don't know if this works out, but the great thing about community projects is they are completely open. Everyone can go to our Discord server and contribute. And when someone funds us, it's obvious that he can read what we're writing. And it's obvious that the result will be open sourced, and no one will try to make great profit out of it or get the best paper or like get like academic advantages. We will just like train the model, burn the money, and push it out with precautions, with disclaimers that of course this is for research purposes only. But yeah, we want to make it as accessible for the general public. So this is our mission as a community effort. We have researchers, we have high school students, we have entrepreneurs, all kind of people working together.
Yeah, thanks for the explanation. Let's see. So while we're talking about scale here, and also noting we're kind of running up to the end of the Q&A session, but maybe have time for one or two more questions. Let's see. So what we're talking about scale, I think it would also be interested to hear from the 3D ImageNet authors. So I had a question from basically saying that it's important for the original image network to respect the scale of the problem. This is something that Fei Lead would tell her students when they're working on ImageNet, respect the scale of the problem. I'm curious, what kind of limitations have you run into, and how can you scale out projects like 3D ImageNet?
Can you hear me?
Yes.
Yeah. Hi. So we started this project. We were working on some 3D depth sensors, and whenever we try to look into some data set for some training, it was a really small number of images, or either there are like synthetic data sets. So my professor and I came together, there should be a way to come up with a way so that we can use the existing sensors which are available in the market, and how can we utilize the existing hardware to collect this large amount of data. Eventually we figured out that if we are facing this problem, lots of people will be facing the similar problem as well. So what we did is we tried to create a front-end application which is connected with the Android application with the backend of a database, so that anybody can upload the database just with a mobile phone and then just use it. From the scale perspective, right now, we are still making some modifications into the data set. The starting is when we are, the first problem we faced was when multiple people are using the web services we were developing, there was an overloading issue in there. So we are migrating the data set from a local machine to an AWS, so that will solve the problem. Does that answer the question?
Yeah, thanks. It's quite interesting to see the different perspectives of crawling the whole internet through Common Crawl versus recruiting and building tools that enable a community of people to create data.
Yeah, if we could crawl the internet for getting the 3D data, we would. But the problem is there isn't much. the whole start of deep learning started when the Facebook said, "Oh, we got a lot of images. What do we do with it?" But here is like the hardware is available already, and people are saying, "Oh, we have the hardware now. What do we do with it?" So we have to start from the other side of the spectrum and start the data. So that's how we come up with this idea.